Question 8. A particle of mass 2 kilograms hangs from the ceiling by means of a light elastic string of natural length 2 and elastic constant 7 newtons per meter. We have to find the length of the string when the system hangs in equilibrium. And then secondly, if the particle is stretched for the distance x, show that the force on the particle is of magnitude 7x. Now, when it's in its equilibrium position, the upward force is equal to the downward force. The upward force is the tension in the elastic K at D, which is K on L minus L0. The downward force is the weight, which is 2G. So at O, upward forces equals downward forces. This means K on L minus L0 equals 2G. The elastic constant K is 7. The length L of the elastic is what we're looking to find, minus the natural length L0 is 2. And this is going to equal 2 times 9.8, which is 19.6. If we bring the 7 across and divide, 19.6 divided by 7 is 2.8. So L minus 2 is 2.8. And then if we bring the minus 2 over, L is going to equal 4.8 meters. So this is the distance from O to the ceiling. Next of all, we're going to extend the particle down a further distance x away from O. So if we extend it down a further distance x, and we call this new position some point Q. Now at Q, the particle is not in equilibrium. This means upward forces does not equal downward forces. The upward force is greater than the downward force. So the magnitude of this upward force is the upward force minus the downward force. So the resultant force F is going to be T minus mg. So T is given by K on L minus L0 and mg is just 2g. So here the resultant force F is going to equal, the K value is 7. The length of the elastic is 4.8 plus x. So we 4.8 plus the x is the L value minus L0, which is 2. And then we have to subtract 2 times 9.8, which is minus 19.6. Now 4.8 minus 2 is 2.8. And when you multiply that by 7, this gives 19.6. We also have to multiply the 7 by the x, and that gives 7x. So F is 19.6 plus 7x minus 19.6. The constants cancel, and F then just equals 7x.